All right, in some cases, it is not really easy or feasible to write the general solution in the explicit form, y equals. Okay, so I'm going to kind of let you know what that looks like if you can't. So it says, given the initial condition, so that means I'm going to be able to take this to particular, find the particular solution of the equation given there, u, right? So one thing to notice, the dx and the dy are already separated. And so you just need to move one to the other side. It doesn't matter what you do. I think that I'm going to leave the e to the negative x squared times y squared minus 1 dy on this side, and I will do negative xy dx on the other side. So I just subtracted that first term to the other side. Okay. I still don't have just my x's and y's alone. This is the side I'm going to have all the y's. This is the side I'm going to have all the x's. So I got to do a little bit of switcheroo here. This is going to end up as y squared minus 1 over y dy equals negative x over e to the negative x squared dx. Okay. But now I'm able to go ahead and take the antiderivative of both sides. One thing to note, on this side, I can't really do a u substitution. It's not a known, right? Because if I do a u substitution, my y's won't cancel. And so this is a rewriting option, right? Y squared divided by y is y minus 1 over y. Okay, so that's what that's going to be like. And on this side, this will be an integral of negative x. And if you have e to the negative x squared under there, that's the same thing as e to the positive x squared. So just bringing it up, I think, makes a little bit of sense over there. So the left-hand side I'm going to be able to deal with. The right-hand side is not a known, but I think if you think about using a u substitution, that will fix it. All right, so I will have negative x e to the u du over 2x. That's going to go. I can pull out that negative 1/2, and then I have my favorite antiderivative of all time, right? Negative 1/2 e to the u plus c. So when I take that back over here, negative 1/2 e to the x squared plus c. On the other side, I'm going to have 1/2 y squared minus natural log of the absolute value of y. That's just known ones. But you might look at this and say, yeah, that's definitely not real easy to get the y alone. Okay, so I don't necessarily need to do that, but I do need to figure out what my plus c is. Okay, and so I'm going to use that y of 0 equals 1, which is the same thing as saying when x equals 0, y equals 1. To go ahead and figure out what my plus c is. Okay, so I'm going to have 1/2 times 1 squared minus natural log of 1 equals negative 1/2 e to the 0 squared plus c. So a lot of nice things can happen. You can see here I just get 1/2 minus 0. E to the 0 is just 1 equals negative 1/2 plus c. And so if you move that negative 1/2 over, you end up with c equals 1. That is not my answer though, right? My actual particular solution would be 1/2 y squared minus natural log of y, absolute value of y, equals negative 1/2 e to the x squared plus 1. So that would be my particular solutions. You also could clear out the fractions if you wanted to multiply everything by 2. All right, so you could write it as y squared minus 2 natural log of the absolute value of y equals negative e to the x squared plus 2. That would also work. Okay, don't forget that you could use your log rules and move that in as an exponent. If it does become an exponent, y squared will always be positive, and so you could actually drop your absolute value there. And sometimes you would see it written all on one side like this. All of those would be equivalent. Okay, so I just want to make sure that you notice all of those alternative forms work as well.